Hello everyone, welcome to the channel. Quantization of large language model is nothing less than a blessing. If it were not for the quantization, most of us won't be able to run these large language models locally. We have numerous techniques and frameworks and toolkits to quantize these models. Post-training quantization or PTQ reduces the memory footprint of LLMs by quantizing weights to low precision data types. All of these LLM inference is usually memory bound. So these quantization methods can improve inference throughput. There have been a lot of techniques which I already have shared on the channel. One recent technique which has just come to my attention is this QTIP or quantization with trellises and incoherence processing. And this seems quite promising to me. And in this video, not only I'm going to give you a theoretical, conceptual explanation of this new technique in as simple words as possible. Plus, we are also going to have a look at one model, which is Llama 3.1 8 billion, which has been quantized with this QTIP technique in just 2-bit. They also have a 3-bit variant, not only for 8 billion, but also for 405 billion model. But before that, let's have a quick look at what exactly this QTIP is. Now, this QTIP is a quantization method to compress large language models. These large language models are complex computer neural networks for natural language processing, but they require a lot of memory and computation power. QTIP helps reduce the memory needed and speed up the processing. It uses a new technique called as trellis. Trellis is a mathematical concept used in computer science and communication engineering. On your screen, if you look at this image, and let me maybe open it to a new screen to better explain it. Now in the middle, you see there is a trellis. Imagine a lattice or a grid with many nodes or points connected by edges. Each node has a value and each edge represents a possible transition between those nodes. If you look at the middle grid, you start at one node or point, then you can move to adjacent nodes through the edges. Each node has a value. The paths you take through the maze represents a sequence of value. In the context of this QTIP, a trellis is used for quantization, which is the process of reducing the precision of numerical values to reduce memory usage. QTIP uses trellis encoded quantization or TCQ to compress LLMs. TCQ represents data as a sequence of values. It uses a trellis to find the best approximation of those values. And it stores only the transitions between nodes or edges instead of the node value, and that is the secret sauce of this QTIP. This approach reduces memory usage and enables faster processing. So, key takeaway is that this QTIP compresses LLMs using trellis encoded quantization. It enables fast inference and hardware efficient processing, and the compression quality is quite state of the art. So that is all we need to know. One thing is that it also uses compute-based Gaussian codes to eliminate the need for large code books. Gaussian code means that the distribution of data that follows a bell-shaped curve, meaning most values cluster around the average, and that is what it is using. And you can see on the right hand side that for the Llama 2, even for 2-bit, it is performing quite well. So for example, this diagram is telling you that with QTIP, 2-bit models have scaled better than theoretically optimal 4-bit model, and you can see that QTIP 2-bit in orange line here. How good is that? Whereas AQLM 2-bit, which we already have covered on the channel, hasn't performed that well at all. Okay, so enough theory. Now let's try to get this installed on our local system and then see how this QTIP in 2-bit works. Before I do that, let me introduce you to the sponsors of the video, who are AgentQL. AgentQL is a query language that turns any web page into a data source. AgentQL is language for extracting data from web pages very quickly and at scale. It uses a Python SDK to run your queries in production using Playwright, and it uses a browser-based debugger for optimizing queries in real time on any web page. It is a robust alternative to fragile XPath and DOM CSS selectors, as it uses the power of AI to analyze the page structure to find the data you are looking for, and I will drop the link to their website in video's description. Okay, so let's now install this model on our local system. I am using this Ubuntu 22.04, and later down the road I'm also going to show you my GPU consumption. GPU which I'm using is this NVIDIA RTX A6000 with 48 GB of VRAM, sponsored by Mast Compute. I will also introduce them to you shortly. So first up, let's create a virtual environment with Conda. Shouldn't take too long to get activated, and that is done. Let's install the prerequisites. Make sure that you install Torch and Transformers from the source because it is quite new, so only those ones are supported. Let's wait for it. It is going to take a minute or two. So while that happens, I was referring to Mast Compute, who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video's description, and I'm also going to give you a coupon code of 50% discount on a range of GPUs, so do check them out. Okay, so let's wait for it. The prerequisites are done. Let's launch our Jupyter notebook, and then we will download and play with this 2-bit model quantized by QTIP in the browser environment. Jupyter notebook is launched. Let's import the libraries and get our this QTIP model downloaded. The model is being downloaded. It's just 3.85 gig in 2-bit, which is, and it's a 8 billion model, the original one, which is quite good. So let's wait for it. And the model is downloaded, and this is just telling you about some of the layers and weights which haven't been used in this download with the pipeline. Okay, so now let's do the inference. And there you go. So the first, I asked it, write a love poem with exactly 50 words. And there you go. So it has written this English poem, which is not bad at all for a 2-bit model. So it is quite coherent. I don't see any mistakes there. It's not a very hi-fi language, but still good enough for a 2-bit model. Really good stuff. Let's see if it can do the maths here. So I'm just going to give this equation. Let's wait for it. And there you go. In a typical Llama fashion, it has done the step-by-step thing, and the answer is quite correct. So math is also good. Let's try out a coding once. It's a simple Python function. Let's see if it can write it to calculate the area of a rectangle given its length and width here. Very nice. So you see, it has written the Python function, and then it has even given us example usage with the some of the commentary. Awesome stuff. So you can see that the performance and the quality of this QTIP method is quite good. I'm very impressed by it. If you want to play around more with the code base, you want to try out some of the quants and quantization or fine tuning, you can go to the repo and then maybe tinker with this script to run it. You might have to adjust some of the hammered packages and that sort of stuff, which is a bit pain in the back. This is what I'm talking about, because these are very, very early days. So I'm hoping that this is going to improve further, and this documentation will improve further in the future, but still really good stuff. I will drop the link to this repo in video's description. Let me know what do you think. Also, if you are interested in learning more about different quantization methods, go to my channel, just search with quantization, and you will see that in the last few months I have done heaps of videos on different quants. I was quite impressed by this one, which is Quip, so also do check it out. And then there are a lot of other quants which I have done. As you can see that there are heaps of videos around quantization from different angles, different tools, different frameworks with different models, including text and vision. And if you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network, as it helps a lot. Thank you for watching.